Hello everyone. Good morning. Can you hear me? Can anyone hear me, please?
Yes.
All right. Thank you. Good morning once again. So before we start for what we have for today, what we covered yesterday, were you able to try it out? Was anyone able to complete the labs on their own? Okay, Zeddy said not yet. Anyone else? Okay. All right, so I'm going to go through what we have for today. It's going to be a continuation on authentication vulnerabilities. Then I'll give us over the week to complete the labs. So I'll probably ask during the course of next week to ask us how far we have gone with the labs. So I'm going to go ahead and share my screen, and I think we'll just pick up from where we stopped yesterday. Okay, so I believe you can see my screen. So yesterday we started looking at authentication vulnerabilities. Discussed what authentication is, difference between authentication and authorization, and then how we can explain some simple authentication vulnerabilities. All right, so we covered, I think we started looking at vulnerabilities in password-based logins, and we were able to complete the username enumeration via a different response, and also username enumeration via sub two different responses. So we are going to look at the third lab we have here. Then, so basically, I'll just be going down this list and see how much you can cover. I may not cover everything on this list because I want to also talk about vulnerability in multi-factor authentication. I think that's also important. So I'm going to walk us through a few more of these labs, then move over to vulnerabilities in multi-factor authentication. So looking at this next lab, which is going to be username enumeration via response timing. So let me put this link on Slack, just in case anyone is following along. Um, so similar to the other labs we have seen, they told us this lab is also vulnerable to username enumeration, and we have covered what that is in class yesterday. So if you're not in class yesterday, please you can go over the recording when it is, I think when it is shared. So to solve this lab, we need to enumerate a valid username. We need to brute force the user's password and then access their account page. So what we are going to do is click on access the lab, right? So we want to access the lab and see what we have so we can know how to attack it. I'm going to click on access the lab and let it start an instance for us. So we also have a blogging application similar to what we have yesterday, what we saw in the two other labs yesterday. So I'm just going to copy this instance URL over to the Bobsuit browser because we can easily work from here. Okay, so we have this. Like we discussed, you can click on each of these posts, view what is there and all that. But we are interested in username enumeration. So I'm going to head over to the my account section. So if I go to my account, we also see we can't register an account. So we have to find a way to enumerate valid username and the password. So I'm going to enter admin as username and just type anything on my keyboard as a password. Click on login. Says invalid username or password, as we'd expect. But going back to Bob Suits. So going back to Bob Suits, under the HTTP history, I have this login. This is the credential I entered, admin and anything as the password. So like we did yesterday, I'm going to send this over to intruder, right? So send it over to intruder. We want to vote first for the username first. So I'm going to highlight that, click on add, and then under payloads, we need a list of usernames. So I'm going to go back to the lab. We have candidate usernames. Oh, we haven't given some credentials. So let me see over here. We have some credentials. So our credential is Winnie. Username is Winnie, and the password is Peter. Let me see if we have credentials. What can we do? Okay, so I'm going to come here and log in with that credential first, right? So username we're given is winner and the password is Peter. If I log in with this, we have this account. So we have this user account. And what is expected for us to do? So we logged in, but we're not able to, we didn't say we have completed the lab yet. So we probably need to find another valid username to use. I'm just going to go back to Bob Suits. First off, I want to copy this username list here. So copy everything and go back to Bob Suit and paste it here. So once that is done, I'm going to click on start attack, right? We want to see what happens. I'm going to click on start attack and that should start. I don't know why this keeps going back here, but this is what I want to. So this will start the attack. And let's see if we get anything interesting back. So everything is still 200. The length still looks the same. I'm just checking the response to see if we have anything different. Okay, so we see something right here. Instead of getting incorrect username or password, this is telling us that you have made too many incorrect login attempts. Please try again in 30 minutes. That means this particular application we are testing has some form of IP address protection, right? It has some IP-based brute force protection. So whenever we try to send multiple requests in a very short period of time, we get blocked. So currently, my IP address is blocked here because we have sent too many correct login attempts and we are told to try again in 30 minutes. So I'm going to cancel this, stop this attack, and look at the request more and see what we can actually do. So let me see. So we have this is the actual request we're sending. So I'm going to click on clear just to remove everything. And at this point, there are a couple of things we can do. So as hackers, most times what we do is when we see something we don't understand, we generally just Google around and see if we can find solutions to it. So I know there's some IP-based protection. It's blocking my IP address. So I'll probably go to Google and look for IP-based brute force protection bypass, right? I know my IP address is getting blocked, so how can I bypass it? That's what I've just searched for. So I searched for IP-based brute force protection bypass. I know that's the protection in place. Then we want to see if it's possible for us to bypass it. And one of the results I'm getting back from Portugal is saying that we can add the X-forwarded header to bypass IP-based brute force protection. So we know that the particular request is blocking our attack based on IP address. So it's blocking the IP address, telling us to log in like 30 minutes. But if we add the X forwarded for header to the request, we may be able to bypass that particular protection, right? So I'm going to go back to the request now and see if that's possible. So in the requests, we can edit this request and X forwarded for. If you read more about it, it's a header we can add in our HTTP requests. So anywhere here, it can be anywhere really. So I'll just go to cookie and add the header here, X forwarded for. And what this header takes is we can give it an IP address. So what happens is when we send this request to the web server, to the application in question, automatically our IP address is sent with the request, right? So the backend application knows the IP address we are sending the request from. And it sees that that particular IP address is sending multiple requests. So that's why it blocked our IP because it knows the IP address we are sending from based on the request. But when we ask S forwarded for header in a request, that's like saying the particular address we supply here is forwarding. So when we send the request, let me go over that again. If we are using the X forwarded for header, what happens is that the application is going to think that we are sending the request on behalf of another IP address, right? So even though the request is coming from my IP address, the application is going to say that, okay, since there's X forwarded for header, that means I must be forwarding the request for someone else for this IP address. So now, to demonstrate this, I'm going to send this to repeater first. So X forwarded for, I'm going to say 1.2.3.4. This can be anything. It doesn't have to be a valid IP address, but I'll send it to repeater. And even though our IP address has been blocked before, if I go ahead and send this request now, it will probably go through. And it says, let me see, so incorrect username or invalid username or password. That is what I'm getting back here, right? But if I send this multiple times, so I'm going to click on send a couple of times. I could use intruder for this, but I just want to show us from here and see what happens. So I click send a couple of times and you see what happens here. It says you have made too many login attempts. Please try again in 30 minutes. That means this particular IP address has been blocked. But currently, my X forwarded for header is 1.2.3.4. What if I change it to 1.2.3.5 and I send the request again? Now, it's telling me invalid username or password. It's no longer telling me I've been blocked, right? That means we can bypass that protection by simply just giving the X forwarded for header a different IP address. So when we change that IP address, the application will think that, okay, the request is coming from a different IP address, not the one it has blocked before. So even though it's a kind of protection put in place, we can still bypass it as long as we supply a different IP address. And that is what we are going to do for this particular request. So I'm going to go back to um, intruder and set this IP address as 192.1.2.3. Let's say 9, the X forwarded for header. So I just added that part. The username field is still what we want to put for. So I'm going to highlight that and click on add. Then I'm going to go to, we still have the word list in the payload. So I'm going to just click on start attack to start a different attack now. Let me share that screen as well. I don't know why this keeps going back to Okay, so that's going to start the attack again, and at some point, it will probably also block us, right? So I'm just going to give that some minutes to finish. Okay, so if I check the response here, no, sorry, response, it's saying we have so many login attempts. So we are probably blocked already at this point. So instead of doing just one brute force attempt, right? We are currently just brute forcing for the username. And what is happening is that whenever we do just that, at some points, our IP address is going to get blocked. But one good thing about intruder is that we can actually brute force for multiple values at a time. So rather than brute forcing for just the username, we can also replace our X forwarded for header automatically. So we can keep changing this IP address and at the same time keep brute forcing the username. And the way we do that is, first off, we need to change the attack type. Right, so currently the attack type is set to sniper over here. And if you read the description for sniper, it uses a single set of payload, right? So we can only brute force one position with sniper. But we can use pitchfork, which is a different type of attack, but it uses multiple payload sets because we want to brute force for multiple things. So for the S-worded header, it's going to take an IP address, which is just numbers, and then for the username, it's going to be text. So we want to brute force different payload sets. So I'm going to select pitchfork as the attack type. For the X-ordered for header, we need to change just one particular. So an IP address is 4 octets, right? We need to change just one octet. So 1.2.3 dots. The last octet is what I want to change. So I'm going to add a value there. So I'm going to click. It can be any of the octet actually. I'm not selecting the last one. Click add. Then also the username we want to brute force. I also highlight that and also click on add. So we have two places we want to brute force, right? So now under the payloads, we need to do something different. So I'm going to clear this list first. So for the payload, we know that the first payload we set is this IP address part. So that means that one is going to be numbers. So payload set one, I'm going to say the payload type is going to be numbers, not a simple list like we have there before. So this one is going to be numbers. And I'm going to say between number 1 to number 255, right? So between 1 to 255, that's the range of a valid IP address, or I can say 254, just to be safe. So between 1 to 254 is what I want to replace here. So that means what's going to happen is that whenever I send a request, this is going to be 1.2.3.1, 1.2.3.2, 1.2.3.3, like that, all the way to 255. And for the second part, which is the username part, uh, so the payload set, I'll go to number 2 because we want to brute force for two things. So I'll go to number 2. That's going to be a simple list, and I'm going to copy the username list again. Uh, Let me see, do I have it? Okay, let me just click that again and copy the username or usernames rather. So copy all that. Let me go back to pop suit and I can paste it here again. So now we are brute forcing two things at a time. So we are automatically changing our IP address and at the same time, brute forcing the username value. So we should no longer get blocked like we got blocked before. So at this point, we should no longer get, our IP address should no longer get blocked because our IP should keep changing, right? Okay, so and I also want to make other change to the first payload set. I'm going to say between 1 and 100. And that's because our username list is also 100. So I don't want to go more than our username list because this is also 100, right? So the payload for the IP address proof is going to be between 1 to 100. And also our username list is also 100. So that should make them equal. So once that is done, um, once we have set all that, I can now click on start attack again. So again, the whole idea here is that our IP address should no longer be blocked because it's going to keep changing. So you should no longer get that you have been blocked message. So if I come here, if I click on any of the requests, so this very first one, you can see that our IP address is the X forwarded for header here says 1.2.3.1, the part I'm highlighting. If I go to the next one, it is 1.2.3.2. If I go to number 5, it's 1.2.3.5. So it's going to keep changing. And if it keeps changing, that means the IP address should also keep changing the way the application sees it, and we should no longer get blocked. So that's just one simple trick we can use. If you notice that there's an IP address-based protection in the application that blocks you from brute forcing. If you notice that it's blocking your IP address, this is one simple trick you can use to bypass things like that. So we can just use the X forwarded for header to keep changing our IP address. So the application we believe is coming from a different address, so it won't block the request anymore. So I'm going to wait for this to finish and see if we get anything interesting back. So it's currently 60 out of 100 or 61 now. So I'll give it like a minute more or two. It should be almost done now. Okay, so it's done. I'm going to click up here and okay, I can't filter. Yeah, really. So we know that the whole lab is about checking the response time. We want to do username enumeration by response time. So I'm just going to look for any one of them that has a very long response time. And the way we can do that um, is to use the response received uh, field. So if we check the response received, they kind of vary, but we know we can do enumeration based on how long a particular response is. So if I look at this one, for example, the response time is 6274, which is quite longer than almost every other one, right? So if I look at every other one is like 176, 183, 195, 184. They are quite low, But the only one that is much longer, that means it takes more time for the application to respond. So the one that takes more time for the application to respond is the, let me see if I can find it again now. It's about 6.2 something. So everything is below 200, and why this one is actually over 6,000 milliseconds. I think it's milliseconds. That's how long it took the application to respond back to us. So I'm going to take note of this username. The username is AN. Just the username I requested here is just AN. So I'm going to send the request one more time and see if we still have the same results. So we just, since if you are doing animation using response time, it can be a bit tricky because it may probably be your network that makes the response time to become longer. So rather than doing it just once, we can do it multiple times if we are dealing with animation using response time. So we need to do it at least twice to make sure that it was not your network that interfered with the request. So I'm going to close this. So the username we noted here is AN, right? So I'm going to go back to our payload and I want to make one change to this request. So my password is currently just this. I want to make it longer and see if it's going to affect the request in any way. So I'm just going to paste that particular value a couple of times, right? So the password is way longer. I'm not changing anything here. The exported for header is still the same. Username is still the same. The payload are still the same. And I'm going to start the attack again. So let me start. So let me share this again. I don't know why it keeps going back to this place, but okay, so that's the attack has started again. I'm also going to give it some time to complete as well. So the whole idea here, what I'm trying to look for is if the AN username also gives us a very long response time. So the first time we checked, the response time was over 6,000, right? It may be due to network connectivity or not. So the reason I'm running it again second time is to confirm that it's actually taking longer for that particular username to respond than the other ones. So if after running this again, once it is done, if I notice that AN is still taking longer to respond than every other username, that means that's probably a valid username and we have an incorrect password, right? So I'm going to now use that username and then we'll first for the password after that. So we'll just wait for this to finish. And let me see. I don't think we have gotten to AN yet. So it's currently 58 out of 100. I'll give it like a minute more to finish. Mhm. Okay, so this is done. I want to click up here and we have the response received column showing already. We also want to select the response completed, right? So we have two fields to look at. So we have the response received and the response completed. And if I scroll through, they are mostly like the same value, but I'm going to keep scrolling down to see if we have anyone that is quite larger than every other one. So we have this particular username, ADSL, which is different from AN that I saw earlier. So when we are doing username enumeration using response time, it can be a bit tricky actually. So the reason AN was quite large was maybe due to network issue or something like that. This time ADSL is much more larger, so it's over 6,000. If I scroll down to AN that we saw earlier, it's now about 140, which is similar to other ones. So now we have two candidates, AN and ADSL. So again, I'm still going to do the same thing one more time to confirm which one is actually the correct username we may work with. So we know we have ADSL from this request. If I scroll down to find it. So ADSL here, the response received is over 6,000 and AN is back to 140, right? So I'm going to close this and do the same thing one more time. Doing this back and forth may be actually maybe stressful, kind of, but again, you doing animation using response time can be a bit tricky, right? So I've started the attack once more, and I'm going to again wait for it to finish and see if ADSL still has a very high response time. So I'm going to also, so we are looking at both response received and response completed. So once that is done, I'll compare the values again and see. I think at this point, you'll be able to determine which one is actually the valid username or not.
I have a question.
Please go ahead, Zeddy.
Um, is there a specific reason why you've repeated the password um multiple times? Because the first one we had was very short, and then the second one we've just repeated it, and it's so long. Is
Yeah,
there a
so
specific reason?
I just wanted to, so what happens, like I was trying to understand what is happening behind the scene. So when we supply a valid username, what I think is happening is that if username is valid, it's going to try to compare, check the password if it's correct. And since we are dealing with response time, if I have a longer password, that means it probably takes longer for the application to check if it's correct or not. So the reason I increased the password length was just to make sure we have significant changes in the response time. So if I have a very short password, the application can quickly compare that password and see if it's correct or not. But if I have a longer password, it may take a couple more seconds to do that check, right? So I just want to make sure that I have enough password length to have significant impact on the response time. That's why I increased the length. But ideally,
Okay,
it should not really matter in modern applications.
okay.
Yeah. So this should also be done soon. Okay, so this is done. Again, I'm looking at the response received column and the response completed column to see if any one of them is larger than the others or takes more time to respond than the others. So I'm just scrolling down again and let me see. So scrolling all the way down, all of them now appears to be the same thing. Um, so I'm just going through manually to see if I missed anything. Well, everything now appears to be the same thing actually. I mean, they look similar, but I'm going to look for ADSL because so ADSL is 193.203 and that a much larger response the other time. So I'm going to try ADSL as the username. If that doesn't work, I'm going to do this all over again, right? So I'm going to uh, close this. Then under the brute force payload, I'm going to clear. So we only want to brute force the IP address this time. That's the only thing we need to change. For the username, I'm going to call it ADSL, which I have a feeling will not be the actual username, but I'll say ADSL. Then I will try to brute force the password this time. So let me see. Add. So I'm saying the username is ADSL and I want to put first the password. Under payloads, I can still leave payload one as numbers. About payload two, we need to supply the password list, not username list now. So I'm going to clear this. I'll go to the browser and open the possible password list and copy everything here. So copy, and if I go back to box suit, I can paste that here and then start the attack again. So at this point, what we are looking for is to see if we get a TVO2 response, just like the ones we did yesterday. So and wherever, if we are able to get a TVO2 response code under the status code, we are able to get TVO2, that means we have found a valid username and password. If not, that means we have not gotten the correct username yet. So I'll probably need to do that username enumeration all over again and see if we find a valid username. So doing enumeration using response time is one tricky thing that's, I mean, it takes a while to get it right because of the back and forth you have to do. And that's because your network may be one factor that affects the response time. It may not be the application entirely taking time to respond. It may be your network that is interfering with the request. So that's why we have to like do it multiple times. But if this finishes and I don't get a TVO2 status code, I'll probably do the username enumeration all over again. And also for everyone on the call, please send hello to the chat. Um, we can hear me. Send hello to the chat so I can take notes. Okay, so this is finished, and I'm going to filter through status code, and everything looks like it is 200, right? Nothing different. So probably have a wrong username. Uh, that means I have to do this painful exercise again, right? So I'm going to close this and then clear this. We want to do username enumeration again. So we still want to brute force IP address and brute force username. So under payloads, under the second one, I'll need to paste usernames again. So this is passwords. Can I change this to usernames? Okay, so this is the username list. I'll just copy. So I'm just doing the exact same thing I did before again, and do that until I find a valid username at least. So we have the username list here. Again, I'm going to click on start attack. I don't know why that does not show up immediately, but um, so that I started again. Um, uh, so these responses are really a thing. So ADS now appears to have a longer response time than every other one so far. So this is done, right? I'm going to do something different, a bit different. So for the response received, the highest, we have two here. Arizona is over 6,000, ADS is over 1134. So I'm going to repeat these two requests in the repeater tab. So if we go to the repeater tab, we have this same request. So I'm going to again make the password a bit longer than usual. Then the username field, I'm going to say um, username is ADS. So what I want to look for now is if the response time matches what we got from here. So the response time here is 1134 over a bit over a second. So in the repeater tab, I'm going to click on send. And I can check response time from here. So this one says 193 milliseconds. If you can see where my cursor is, that's the response time. So even though ADS is saying 1134 from intruder, this one is saying is 193 milliseconds. And if I send it again, it's saying 150 milliseconds. If I send it again, 193, 183, 187. So even though uh, in intro that was like 113 something, it's actually quite low if I repeat it a couple of times. And let me also check. So you said you have made too many correct login attempts. That's probably why. And let me change this to 6, send, and it's still like 186, right? If I change this to 7, send, it's still like 205. So it's still like pretty low. But if I change the username to the other candidates we have, which is Arizona. So Arizona is also I. The response received is also I here. If I change the username pass to Arizona and send the request. So I'm change the IP address to 8. It's also actually low. So it's 183 milliseconds. If I change it to just changing the IP address, it's also 166. So I don't think any of those two are actually valid usernames. And this is actually one of the reasons I hate doing enumeration using response time, because it can be very stressful. So the reason both of them are quite high here may be because of um, network issues. The other one on this list is Alabama. So that has CH2, which I don't think is also a valid username, but I'm going to try it here. So try the username as Alabama and then see if the response time is high. So I did Alabama and the response time now is 796 milliseconds, which is quite higher than the other ones we have been seeing. So I'm going to do it like 2 more times and see if it's still high. So this is 805, it's still high. And if I do, I'm just changing the IP address at this point to make sure I don't get blocked. And this is 780. So Alabama seems to be quite higher than every other one I've seen, every other username I've seen so far. So just to be sure, I'm going to try one more other username from this list, something like administrator, right? So I'm going to try administrator and confirm that that has lower response time than Alabama. So if I do administrator, if I send this request, it comes back in 150 milliseconds. 158 milliseconds. So Alabama seems to be the one that takes more time than every other one. So I'm going to try Alabama again. And it takes 853 milliseconds. So it's taking more time than every other one we have seen so far. So I'm going to supply that as the username now and see if we can get a valid password this time. So under here, I'm going to clear again the username. I'm going to say the username is Alabama and vote first for the password. So what are the payloads? We still have the payload set 1 for the IP address, which is fine. What we need to change is payload set 2. So we have the username list. I'm going to clear and select the passwords list. So I want to copy everything here. and hopefully we'll get it right this time. So paste that as the password list, then click on start attack. Um, I don't know why that changes every time, but so the attack has started now, and hopefully we'll get a 302. So when we are requesting for password, after supplying a username, what we are looking for really is a 302 response code. We want to know if you have found a valid password or not. So rather than filtering based on response time now, since we are checking for password, I'm going to filter based on status code. So if you're able to get a 302 response, that means we have found valid credentials. Um, I'm going to wait for it to finish, but so far everything I'm seeing is still 200. I hope this is actually the correct username because, but if it isn't, I'm going to allow us to try it on our own. I'll probably move on to MFA because we have spent over 1 hour on this one. But doing username enumeration using response time is always painful. But I'll let the attack finish first and see if it finds a valid password. But if it doesn't, I'm just going to pen that down. Uh, you can also try it at your end if eventually you find a response time that works. And then I'll move on to discuss MFA. But that's generally how you go about doing enumeration using response time. You just do it a couple of times till you find something that's to define the particular value that has a larger response time or a longer response time than every other request you make. So this is done if I filter for status code. Okay, yeah. So it actually found one. So there's a 302 here, and that value says mobile mail. So Alabama is the username. Password seems to be mobile mail, and we get a 302 for that. So I'm going to copy the password of mobile mail and then go to our application. So for username, the username we found is Alabama, and the password is mobile mail. Click on login, and we're able to log into this user account, and also we have been able to solve the lab. So generally, that's how you go about doing enumeration using response time. You just to do it a couple of times, so you'll find something that actually works. It's actually one of the least interesting ways I use for enumeration, but it's one of the techniques out there we can use. So going back to port figure here, I'm going to close this. So we have completed this lab. So I'm supposed to talk about flood boot force protection and things, every other thing here, but I will this link has been shared with us already, so you can read through these things and also try the labs if you can, see if you can complete the labs on your own. But just take note of these things all the way from flood boot force protection down to everything we have here. So the next thing I want to talk about is vulnerabilities in multi-factor authentication, which I think is really interesting because most applications nowadays, they tend to have some kind of MFA implemented, right? Where after you log in as a normal user, they still require you to have an OTP, either sent to your email or to your phone number or something like that. And even though they are added security measures, they can also have flaws if they are not properly configured. So first thing is to discuss the vulnerabilities that can occur in MFA mechanism. Let me see. So many websites, they rely on single factor authentication. So where they ask you for just a username and password to authenticate. But some websites also have MFA implemented. So they require you to prove the identity using multiple authentication factors like OTP and things like that. So verifying biometric factors is impractical for most websites, and it is common to see both mandatory and optional 2FA authentication based on something you know and something you have. So that requires users to have both traditional password and also a temporary verification code from an out-of-band physical device in their possession. So something like an email or an OTP from your authenticator app, right? So when we talk about two-factor authentication tokens, so verification code are usually read by the user from a physical device. So something like Google Authenticator, for example, some of us may be familiar with Google Authenticator or Microsoft Authenticator that you can use to receive, that you can use for OTP, right? You can enter the OTP and you get logged into your account. But most web applications don't get to use secure mechanisms like Google Authenticator. Some people try to design their own OTP mechanism, their own MFA mechanism, which is where the vulnerability can come from. So some websites tend to send verification codes to users' mobile number as a text message. Some send it as email address. But if you are sending it using mobile number, the first thing is that particular OTP is transmitted using SMS rather than being generated by the device itself. That means what is happening is that the application, the backend is actually the one generating that code and sending it to an SMS or sending it to an email, which makes it less secure than something like Google Authenticator. So Google Authenticator is kind of time-based, right? And the code you are using is generated on the device itself, so it cannot be easily attacked. But when the developer or the application is sending the code to the user using SMS or email, that means it was generated on their own application. And if that is the case, we can find ways to abuse it. So that means the code can either be intercepted or things like that. So I'm going to now talk about how we can bypass 2FA authentication. So at times, when you implement 2FA, it is flow to the point where it can be bypassed altogether, right? So in some applications, you may need to brute force the code if there's not a protection. In other cases, we are able to bypass OTP, MFA altogether. So we're able to bypass MFA altogether. So if the user is prompted to enter a password and then are prompted to enter a verification code on a separate page, the user is effectively in a logged in state. I'm just trying to read from what we have here. uh, I'm just going to go to the lab directly and use that to explain. So we can read the description here. I'm just going to walk us through the lab and use this to explain. So for this particular lab, it uses two-factor authentication, which can be bypassed. We have a valid username and password given to us, but we need to be able to enter the 2FA code. So that is the challenge for this particular lab. We have credential, we have a correct username and password, but we need to be able to access the user's email so we can get the 2FA. So I'm going to click on access the lab. So that's going to start an instance we can work with for us. Okay, so we have this page here, which looks like, again, another blogging application. But if I go to my accounts, we are asked to enter a username and a password, right? And in the lab description, they give us our credential. So our username is Wayner, password is Peter. So I'm going to enter username as Wayner, password as Peter, and click on login. Now, this one is asking us for our 4-digit security code, which we don't have. But something we have up here, we have an email client, right? So I click on this email client, it will probably be the email for our address. So is the reason we have that here is because it's a lab, so you kind of need access to the email client. But if we check this email, we get a message that says your security code is 0247. This is what we have here, 0247. That's our OTP code. And if I enter that here, we'll probably get logged in. So we are logged into this account. But the challenge, the actual lab wants us to log in into the victim's account. And that's how we complete the lab. So for the victim, username is Carlos and password is Montoya. So I logged out of this already. I'm going to go back to my accounts, enter the username as Carlos, password as Montoya as I copied, and I click login. Now the challenge is we need to get OTP for this account. And if I go back to the email client, we will not have that OTP sent to us because we should not have access to that person's email. And in an ideal application, I should only have access to my own email address, and the OTP should only stay to my own email address. When I try to access someone else's account, their OTP should not get sent to me. So Carlos' OTP will not show up here, right? That is as we expect. That means we can't log into this application at this point. So I'm going to go back home and do one more thing. So under my accounts, I just went back and clicked on my account and it says we have completed the lab. And this may look very easy, but I'll try to explain why it works. So what the application is doing is that when we logged in into the application and it's asking for OTP, in a secure application, we should not be logged in yet, right? We should not be able to access other pages unless we are supplied the OTP. But this application, because it is vulnerable, once we are able to supply a valid username and password, it automatically logged us in. So it didn't wait for us to supply the OTP first. It has already logged us in. That is why if I try to access any other page like the dashboard, I'm going to be logged in. And that's why it's showing us as logged in here. So this particular vulnerability, it looks very simple, and honestly, you won't find it in most applications these days, but it's something you can easily check for. So the idea is once you are able to log into the accounts using a valid username and password, and it's asking for OTP, before you supply the OTP, you can check if you can access sensitive pages like your dashboard first. If you can do that, and the application does not ask you for the OTP again, that means you can entirely bypass the OTP itself. So this one is a very simple one. I'm going to close this. We didn't even need to use Bob Source. That is how simple it is. So I'm going to close this one and go to the next lab, which should be more challenging. So this one talks about flawed two-factor verification logic. So this is a bit higher than this one. So this one is the OTP. It's going to ask you for the OTP, but it is flawed. So sometimes flawed logic in two-factor authentication means that after user has completed the initial login, the website does not adequately verify whether the same user has completed the second step. And this one is interesting. So after someone has logged in with a valid username and password, the site does not seem to verify if they are the actual one trying to complete the OTP, which is a very silly vulnerability, but there's one particular one I'm interested in taking us through actually. So what I'm going to do is, this first one, we have completed it together, right? You can try this one on your own. This second one that talks about flawed two-factor verification logic. I want you to take a look at it, try to read the description, and try to complete the lab. See if you can lay your hand on it and complete it. What I actually want to walk us through is brute forcing 2FA code. This is what I get to do in real engagement most times, where you try to brute force 2FA code, right? I'm going to go into that because it's more useful for the real world in real applications. So, like passwords, our website needs to take steps to prevent brute forcing 2FA code. So there are times that you get 2FA code sent to your phone and they tell you it's valid for 5 minutes, or it's valid for 10 minutes, or it's valid for 30 minutes. And that code is like 4 digits long. The vulnerability there is that when you have a 4 digit OTP, that means the possible numbers is just from 0000 all the way to 9999. That means you have about 10,000 combinations for that OTP. That means if someone is able to brute force all values between 0000 all the way to 9999, they'll be able to get the OTP, right? They'll be able to brute force it. That is why there should be protections in place against 2FA brute force. But most applications don't really have this protection. Most real world applications, most modern applications as we have it today, they don't have protection against 2FA brute force, right? That's why we are going to take our time to look at it. So it's especially important because the code is often a simple 6 or 4 digits number, like I was trying to explain. And without adequate brute force protection, we can easily crack codes like that. So some websites attempt to prevent this by automatically logging a user out if they enter a certain number of incorrect verification codes, but it's ineffective in practice because an advanced attacker can automate that process. So since we know that we need to just use about 10,000 combinations, rather than doing it manually, we can actually automate the process using something like Intruder. So we have looked at Intruder a bit, the Bob Intruder a bit. So for this one, I'm going to be using the Turbo Intruder extension, which I think we have installed in one of the classes. If not, I'm going to walk us through the installation again and then use the Turbo Intruder extension for this brute force. And the reason I use Turbo Intruder over Bob Intruder in this case is because Turbo Intruder is way faster for doing this type of attacks than the default Bob Intruder. And this lab is also said to be an expert lab, so hopefully it won't be too hard. I'm going to click on this, and again, we are told that the lab software authentication is vulnerable to brute forcing. We have already obtained valid username and password, which we have in our credential here, but we don't have access to the user's 2FA verification code. So to solve the lab, we need to brute force the 2FA code and access Carlos's account page. That is what we need to do to complete this lab. So, and we have something to note here. We are told that the verification code will reset when we are running our attack. So we need to repeat the attack several times before we succeed. And that is because the new code may be a number that your current intruder attack has already attempted. So we need to take note of that. It may change. The OTP may change over time. So we need to use something that's going to be very fast as well. So what I'm going to do is, first off, go to Bob Suits. So I'm going to go to Bob Suite first. And if you don't have Turbo Intruder installed before, I think the way we can install it is in Bob Suite, at the top here, where I have my cursor, you can go to extensions. So if you go to extensions, you can go to, by default, it's going to be under installed. This web should probably be empty for you. You don't have anything installed. Or you can go to B App Store. So if you click on B App Store, you can search for Turbo here. So if you search for Turbo, you probably have this Turbo Intruder extension. Then you can just click on install down here. Please give me a minute. Okay, so you just need to search for Turbo Intruder in the extension, then click install here, and it's going to be installed. Then once it's installed, it may not be loaded by default. So you need to click on check this box that says loaded, and that should load the extension. So once you have it installed and you have the extension loaded, now we can see how to use it. Okay. So I'm going to go back to this browser, click on access the lab, right? Because we need a lab instance to work with. So I'm going to click on access the lab. And once it starts up an instance for us, I'm going to copy the URL to the Bob Suite browser to make it easier. So I'm going to copy this link and I'll go to Bobsuit browser and paste it here. So this is the one we want to work with. So again, it's a blogging application. Under my accounts, we can supply username and password, which has been given to us. The username is Carlos, password is Montoya. So I can copy that, supply that here. So we get logged in, but it's asking us for a security code, right? I'm going to enter 1234 here. It can be anything, right? Just 4 digits. Click on login, and that's going to say incorrect security code. But if we go back to Bob Suits under proxy, under the HTTP history, we can see what happens. So this is the request that we use to log in. Username is Carlos, password is Montaya, but this is the one for OTP, and this is the 1234 I entered. So this is what we need to brute force. So the way we use Turbo Intruder is that on this request, I can right click anywhere. So what we were doing before was to send to intruder, but for this one, I'm going to be using Turbo Intruder, like I said. So you need to go to extensions. If you have Turbo Intruder installed, once you go to extensions, you will see Turbo Intruder listed here, and just click on send to Turbo Intruder. And that should bring up a new screen, which you are not seeing currently, but let me share that. Um, so that will bring up this new screen. So for Turbo Intruder, we need to specify where we want to brute force. And the way we specify where to brute force in Turbo Intruder is to use the %S character. So since I want to brute force for OTP, I'm going to say, I'm going to remove this 1234, and I'm going to replace it with percentage. So Shift and 5 for percentage, then S. That will tell Turbo that is the particular value I want to brute force. And then I need to supply a word list, right? So I already have a word list here that contains numbers, but the word list is just 000 up to 9999. Because of the OTP timeout issue, I'm going to run this first. Let it run. Then I'm going to show us how to generate these numbers after that using Python. So what we need to do here is to click on attack, and that should start to do the OTP brute force for us. And hopefully we'll find a valid OTP code. And almost this is okay going through. So it's doing the checks and is giving us results back. So I'm just looking for anyone that gives us 302 or allows us to log in. And hopefully the time has not passed. So if it doesn't find a valid OTP now, I'm just going to do the request all over again. So try to log in again, then find the OTP again. Um, but if this doesn't work eventually, I'll just try Bob Intruder itself. That may be a bit slower, but I think it's going to be um, more guaranteed to give us a response than this. And that's because it's just telling me null, right? So I'm going to host this first. I'm going to use Bob intruder and then maybe come back to Tubo after. So what we want to do now is we already logged in as Carlos. We want to put first the 2FA again. But what we need to do is under Bob, under projects, we can go to I'm looking for a particular field. Oh, so I can't see that. I was looking for a particular field in Bob, but I can't find it. So the OTP will probably have expired. I'm just going to do this one more time. So I'm going to enter any value again, click on login, and that'll probably that'll probably log me out, right? So click on my account. Username is Carlos, password is Montoya. So it's asking for OTP again, all right? So I'm going to say 1, 2, 3, 4 and try to do the brute force again. Hopefully it's going to see it this time. So I will send this to Turbo Intruder again. And let me see. Let me see. Can I bring this down? So percentage S to show where I want to brute force 4 and then click on attack. And hopefully to find this time. While that is going on, do we have questions? I know it's probably confusing, but do you have questions so far? Can we all hear me?
Yes, we can.
Okay.
None at the moment. We're just following through, I think.
Okay.
So can you help
Okay.
me set up?
Was someone saying something?
Yes.
Talia, your voice is low. I can barely hear what you're saying.
Can you hear me?
Yeah, can you hear you now?
Can you help me set up Babsuit? I've downloaded it, but now I don't know how.
Did you double click what you downloaded? If you downloaded the exe file, you just need to double click it and it will install. But I can take a look at that in a minute. Please hold on. I can host this and configure. So I'm going to, it's kind of going to be a cheat code, but I want to do something. So if I request, I will explain this later. Hopefully, if request code equals to 302, then table dot add um, I probably need to do this all over again, but let's see. Let me just run it again to be safe. Um, so I'm going to go back here and make sure it logs me out, right? Yeah, so make sure that logs me out. Try to log in again. So requesting for OTP, 1, 2, 3, 4, that's going to be invalid. But if I send the request now to going further, um, to set this to Tubo Intruder and say if the status code is TBO2, that means if I get a redirection, I want it to print that code for me. I'm just trying to save time and see if it's going to find a valid OTP. Okay, so where that is, I think that's going to take a while. That's if it's going to find it eventually. Talia, can you share your screen? So I walk through the installation. Talia, can you hear me?
Yes.
Okay, so I'm going to stop sharing and you can share your screen, please.
Can you see it?
Yeah, you just need to click on next. Then click on start book. Have you started?
Pardon, I didn't hear you.
Like as the application started. Yeah, exactly. This is what you need. So it's fully started now.
Okay.
Yeah. Zed, did you want to say something? So I'm going to stop sharing your screen. And so the attack I'm doing is still, I mean, it's still going on. Probably take more time. But I think what I'll do is for the other ones we have looked at, right? Um, Let me see. Where is it? So for these other ones, especially the ones under the password-based authentication, so you can go through this, try to complete the ones we have done. Since most of us have not actually practiced what we did yesterday, so you can practice that, try to complete the labs. Then also to the so these other ones, all these flood with first protection, and you can attempt them as well. But most importantly, this theory we have covered, I want you to attempt them. Then once you have completed them, I want you to send me a screenshot like we did for TryAcme. So once you have solved for all three here, you can send me a screenshot. So I take note of that. And you can do some reading on these other ones. For the multi-factor authentication, I'll probably look for other ways to go about this, right? So sending this request through the internet may take a while because of the network issues, network differences between both of them. This is still going on. I'm not getting any response back yet. So I'll probably write a simple Python application to demonstrate that during the next class. Yeah, but for now, let's just try to complete the username enumeration pass, try to go through it, try to understand it. And once you complete the three labs, send me a screenshot. And for the MFA, we'll get back to it on Friday. So you have like the whole week to look at the username enumeration portion. You have like the whole week to practice the labs. If you have any questions or any trouble completing any of them, drop me a message. And if you are able to complete the three, send me a screenshot, right? So that would be all from me for today. Do you have any questions or comments?
Yes, I do.
Okay, please go ahead.
I did my try hack me. Sorry, I've just remembered I didn't share the screenshot. I'm sharing that right now on your Slack. And then for the assignment you've given today, could we please have that maybe highlighted on Slack or somewhere? I might forget because I feel like it's a couple.
Oh, yeah, it's about three of them actually. So let me see. So I need everyone to complete. Uh, so I talked about this three, right? So yeah, I'm going to highlight them on Slack after this call. So these three, I'm going to drop a message on Slack for that.
Thank you.
You're welcome. Praise, good morning. I've not heard your voice in a while. Rachel.
Good morning, sir.
Yeah, good morning.
Good morning, sir.
Good morning, Rachel. All right. For the assignment, I'm going to drop it in the Slack channel, like Zeddy mentioned. So if there are no other questions, I think I'll call it a day. So enjoy the rest of your day, everyone. And have a nice week ahead, right? It's still the weekend, but have a nice week ahead. Thank you for joining once again.
Thank you.
Thank you.
Bye.
Oh, sir, I have a question.
Yeah, please go ahead.
What about yesterday's attendance? Because I noted we didn't highlight yesterday's attendance, or are we supposed to send hello as well?
Yeah, I think you're supposed to do that yesterday. But no worries.
I didn't
The call
I
yesterday.
didn't send.
You were on the call yesterday, right? Can you hear me, Zeddy? Can you hear me? But if you're on the call, don't worry. We'll sort it out. All right. Once again, bye everyone.
Sorry, sir. Come again, please.
Yeah,
I think I missed that.
you're on the call
My network
yesterday.
was horrible. Yes.
Yeah, no problem. I'll go to the recording now. I have this chat stuff with me, so I'll go through it. Don't worry about the attendance. Or you can also drop me.
Okay. Thank.
All right.
Okay. Thank you.
Yeah, you're welcome.